look at question 3. Question 3 says the probability of A is 0.3. The probability of B is 0.6. And the probability of B given A is 0.4. Okay, so then they say, what's the probability of A and B? And I'm going to use my conditional formula right here, because I can't use my addition formula because I don't know and I don't know or. So the conditional formula wouldn't help me. I mean, the addition formula wouldn't help me. I've got to use the conditional formula. And since I know the probability of B given A, I'm going to say the probability of A times the probability of B given A is what I'm looking for. So that means it's 0.3 times 0.4, which is 0.12. Part B says, what's the probability of A or B? Well, now I have to use the addition formula because that's the only one with or in it. That's the probability of A plus the probability of B minus their collision or their intersection. So that's 0.3 plus 0.6 minus 0.12, which is 78%. Now in part C, they ask you for the probability of A given B. The probability of A given B. I've got to use the conditional formula because that's all I've got. If I use that conditional formula, this is the probability of A and B divided by the probability of B. I've just rearranged that conditional formula to look like that. So the top of this fraction from part A is 12%. The bottom of the fraction is 60%. And dividing those two things out, we get 0.2. Finally, part D says, what's the probability it's not A and it's not B? This is actually the complement of A or B. And I know from part B of this question, A or B was 78%. So the complement of that is 22%.